Okay.
And then I will, you'll have about 15 minutes with the students, and then I'll come back and lead you through the reflection portion, okay?
Okay. Perfect.
All right, have fun, Amanda. I'll talk to you
Thank
soon.
you.
Mhm.
Hi.
Hello,
Hey.
class. How are you guys?
Oh, doing all right. Yeah.
Doing all right,
I'm
hanging
good.
in there.
Yeah.
Good.
Yeah.
Okay, so yesterday we were working on dividing 1080 by 15, and I saw that you all used different strategies to solve the problems, and that was great. But today I thought that we could take a look at some of different students' work, and maybe we can learn new strategies from each other. Does that sound good?
Yeah, it's like we get to be like the teachers for the other two kids.
Right, exactly. So, do you guys have Leah and Max's work?
Mm-hmm.
Can
Yeah,
we go
it's on my
ahead and
tablet.
get that out so we can take a look at
Yeah.
that? Okay, so let's start by looking at Max's work. So I'm going to ask you guys some questions and feel free to answer when you know. So looking at his work, what do you think the first step was that he took in solving the problem? Ava?
Well, I think because it looks, I think that the first thing that Max did was maybe multiply 15 times 50.
I think you're right. Yes. So is 15 times 50 750?
It is, yeah.
It is. Yes. Good job. So then what would the numbers on the side of the whole problem be?
Me still?
Anyone could answer. If you know the answer, you
Oh,
could answer as well.
yeah, I know.
Let's go to Savannah.
I think that the numbers on the side, the ones that he circled, is that what you're talking about?
Yes, the ones that are circled.
Okay, I think that's what he added up to get his answer.
Right. So the answer of 72?
Yeah.
Yes, you are correct. Did anyone do something similar to the way that Max solved the problem?
I did.
You
I
did.
think I did. Mm-hmm.
Oh, that's good. Perfect. Let's see. So do you think that when he circled the answers, it made it a little easier to find the total answer at the end so he didn't get all confused with all the other numbers?
Maybe.
Yeah,
Yeah, I could see that.
I think it kind of helped keep everything clarified and separated. So I thought that was kind of interesting. All right, let's see. 1 second, I gotta pull mine up. So under the number 1080, we see 750. So we found that he got that answer by multiplying 15 times 50. So what did he do after that step then? Dev?
Okay, so it looks like after he did 15 times 50, he subtracted 750 from 1080.
Right, so then he got the number of 330.
Yeah.
So what do you think he did after that? Did he just repeat the same steps?
Yeah, I think only with different numbers this
Right,
time.
with different numbers.
Yeah.
Perfect. So it looks like you guys got the hang of the way that Max did his solving, right?
I think so.
You think
Yeah.
so? Are there any questions on the way that he solved his problem?
Um,
Jasmine?
I'm just wondering, like, I wonder how Max, like, decided to start with 50.
I was wondering that too. So it seems like he could have
Yeah.
even went a little bit higher if he wanted to, right?
Mm-hmm.
I,
Yeah, that's what I was thinking.
I mean, you could solve it either way you want. I don't think there's a
Mm.
correct way in doing it because if you go up,
Yeah.
you're still going to get the same total at the end. I think that 50 was just a safe number for him to add at the end because adding onto 50 is an
Oh.
easier number. Yes, go ahead.
Yeah, that's what I was gonna say. Is I bet it was probably just an easy place to start.
Right.
Because like multiplying by fives and stuff is usually a little easier.
Exactly. Yeah. So,
Yeah.
I mean, you can just do whatever you feel safe and comfortable in doing, especially if you're not using a calculator or something as well. But
Yeah.
are there any more questions on the way that Max solved it?
No.
No? All right. Should we take a look at Leah's now?
Yeah.
All right. So, let's see. Looking at Leah's, does it look like she started the same way that Max did?
No, it looks pretty different.
It does look pretty different, right?
Yeah.
So do you guys, are you able to tell what Leah's first step was?
Hmm. Oh, I think I
Ethan?
Yeah, I think that what Leah did first, it looks like she was trying out different numbers in the corner there, like
It
15
does,
times 8.
right.
Yeah.
So 15 times 8 was 120, and then 15 times 7 was 105. Do you know why she
Yeah.
chose to try those two numbers?
I have no idea.
No idea. Does
Yeah.
anyone else have any ideas at all?
Hmm. Well, oh, maybe.
Go ahead, Jasmine, you can try.
Well, maybe it's because, like, um, I don't know. So, like, because if you start too high, like 50, like if you had done, like, I started with like 15 times 100, because I was like, well, let's just start really high, and that was way too much.
Way too
And
much,
then I
right?
did, and then I did 15 times 50, like Ava and Max, and that was too low. So I just picked a number in the middle, and maybe Leah did too.
I could see where you're coming from. So Leah actually did a standard algorithm for long division. So the way that she did it was we're still dividing the 15 from the 1080, but we start by looking at the first place values. So in 1080, she was looking at the 1 and the 0. So that just says 10, right?
Yeah.
But does 15 go into 10 at all, or is it too big?
No, 15's more than 10.
15
So
is more than 10. So
yeah.
then she went over and added the 8 into that. So now we have 108 that we're going to divide 15 by. Is 108 bigger than 15?
Yeah.
It is.
Yeah.
So we wanted to get to a number as close to 108 as possible. So in order to do that, that is why she chose to do 15 times 8 and 15 times 7. So her 15 times 8 gave us 120. But is 120 too big?
It's less than 1080.
It is less than that, but if we're just looking at 108, is 120 bigger than 108?
Oh, yeah.
Yes, it is. So that's why she went back down to the 7. So she did 15 times 7 for 105. Is 105 bigger than 108?
Nuh-uh.
No, it's not. So that's why she put the 7 on top. Do you see that up there?
Mhm.
And then did 15 times 7, which gave us the 105 that she placed below the 108. Do you see that?
Yeah.
It's a little confusing at first, right?
Kind of. Yeah, because I can't figure out I can't figure out how she, like, so you're just allowed to leave off a 0?
We are going to add
Like,
that 0 in. Don't worry.
oh.
That was just the very first step that she took in order to find the first number.
Oh.
So now what we did from there, so do you see how it's 105 right underneath the 108?
Yeah.
So we're actually going to subtract those then for the next part. So 108 minus 105 gives us a total of, does anyone know?
108 minus, wait, 3, right?
3, yes.
Yeah.
So she dropped the 3 down below the 8 and the 5. Do you see that?
Yeah.
And then since that 0 is left over, we bring it all the way down next to the 3. So now instead of just our answer of 3, we have 30. Do you guys see that?
So she kind of like saved the ones place for last, kind of.
She did, yes. So we're saving the ones for the last. You are correct.
Oh.
So now that we have the 30, do you guys see the 30?
Mm-hmm.
We're going to
Yeah.
figure out how many times can 15 go into 30.
Oh, that's easy.
That's an easy one. All right, let's see. Jasmine, do you want to go?
So 15 times 15 is, or I'm sorry, 15 times 2 is 30.
15 times 2 is 30. Yep, correct.
Yeah.
So where do you think we would place the 2 since that's the answer?
Well, Leah put it in the one. Well, we all did. We made it 72. We put it
Right.
in the ones place.
Yep, so we're going to put it back on the top up there. So now we have to get a total answer of 0 on the bottom, right? Just like Max did for his area of where he solved. He ended up with the answer of 0 inside of the problem. Do you see that?
Yeah.
So we got to do the same for Leah's. So we're going to take the 15 and multiply it by the 2 on the top. What is 15 times 2? Jasmine?
30.
30.
I have a question though. Like why? How come when Leah put her answer like on the top,
Mhm.
how come it's all the way pushed back on the line?
So it is put, are you talking about being pushed to the right?
Yeah, I
Yeah.
think so.
Okay, so remember in the beginning when we were talking about how 15 is bigger than the number 10,
Mm-hmm.
but then we had to go over and add in the 8, so we had a number of 108 instead of 10.
Mm-hmm.
So we have to keep the
Yeah.
place values in line. So since we went over 3 numbers and included those 3, we need to keep our number right on top of that last number that we used. Ava?
Yeah, so okay, so does that mean, so basically when you're writing your answer for division problems, then you're supposed to, like, you write your answer over the first, like, number that you use to, so like if she, like if, okay, so if we were dividing a smaller number than 10, then
Mm-hmm.
she might start her answer over the 0 in 1080, like the first 0?
Yes, so let's see. Yeah.
Oh.
So if we were just dividing, let's say 2 by 40. So since 2 can fit into 4, we can put our first answer number right above the 4 since we don't have to move over anymore. Does that make sense? Ethan?
Do you have to do that though? Does it matter?
It helps you when you're doing your math and solving, just to make sure that you're following correctly and getting all the numbers. So it's good to keep your place values in place for sure. But yeah, so we were doing 15 times 2, right? That was the last step that we did.
Yeah,
And the answer was
30.
30, correct? So we would drop the 30 back below the other 30. Do you guys see that?
Yeah.
And then what is 30 minus 30?
0.
0, right. So do you think that would be the end of the solving?
I say yeah.
Yep.
Yeah, I think so.
There's no remainders, right?
Right.
Right. Okay, well, good job. Did that one make sense to you guys? I know it's a little more difficult in the way that they did the solving, but that is just the standard way of solving it.
Oh.
Yeah, so did
Yeah.
any of you guys solve that way at all, or no?
I mean, I kind of did. Mine has more steps than Leah's does, I think. But
Yeah.
I kind of did something sort of the same.
Do you want to share your work
Yeah.
with us?
Yeah, I can try. So for mine, I did like, so I tried to figure out the right number to multiply. So I tried 90. I didn't so like you know how well, so you can sort of see, like, you know how Leah was trying out different numbers.
Yep.
I did too. So I
Okay,
did 15
perfect.
times 90, which was too high.
Too big, right?
So I got one for that one's 1,350.
Yeah, that's a little
So
bit too
but
big, right?
yeah, it's too big. And so I subtracted 1,080 from 1,350 and got 270.
Okay.
But so I rounded it up to 300 because 270 is kind of a harder one to figure out. But
Yeah.
I just rounded up to 300, which is 15 times 20. So I subtracted 20 from 90 and got 70. So I knew that would be a good number to try it.
Right.
And I was right, because 15 times 70 is 1050, which is a lot closer to 1080. And I just had 30 left, and then I did 15 times 2 equals 30.
Perfect.
And so I just added 2 and 70 together to get
Awesome.
72.
So you kind of did what Max did then, right?
Because of
The way that
'cause-
he added up and added the multipliers up.
yeah, except for I only had to add up 2 multipliers,
Right,
and
and
Max
that was
added up like a bunch.
one of the questions that one of you asked earlier was why did he choose 50? So then looking
Yeah.
at your work, you can see that you can use bigger numbers if it's easier for you. You just don't have to do as many steps then, right?
Yeah.
All right, so
Great. So, Amanda, I'm going to pause us there just in the interest of time so that you and I can kind of reflect on your experience. So,
okay.
how are you feeling after your simulation?
I'm feeling good. I was nervous at first,
Good.
but it went
Yeah,
well.
yeah. Good. I'm so glad. I think so too. How do you think the student avatars are feeling after the lesson?
I think they're feeling good. I think it was a good introduction kind of into the
Mm-hmm.
standard algorithm because it's kind of
Yeah.
hard to explain, but I think just kind of starting off and
Yeah.
working through it together was good.
I think that's right, Amanda. I heard you're right. I mean, the teaching the standard algorithm is complicated, right? And so you wanted to kind of understand how they're thinking about solving problems to
Right.
begin with, and then really highlighting Leah's as sort of the kind of those baby steps towards solving using the standard algorithm. And I
Yeah.
have to say, one of the things that I really noticed about the lesson that you taught is that I heard a lot of the kids making those connections. I heard a lot of, oh, I see, things
Yeah.
like that
Right.
that sort of helped me understand that they were able to make those connections. So really nice job there.
Oh, thank you.
So, I mean, I think I kind of I may have already answered this question, but in relation to the outcome and the strategies, what do you feel like you did well in this conversation or in this lesson?
I think making sure that they're on the same page as me before moving on
Mm,
was the best way to go about it. And I think that that helped me as well. See that sometimes kids are going to need a little extra help or
mm-hmm,
have some questions
hmm
that they need answered before moving on. So I think
Yeah.
the feedback that they gave as well was very helpful.
Yeah, and I'm really encouraged to hear you think of their questions as feedback and sort of describe them as feedback because one of the things that I also noticed and thought that you did really well was you held space for their questions. When they interrupted your flow to ask a question, you saw that as an opportunity
Right.
and you were asking clarifying questions, really making sure that they understood before you moved on. So
Yes,
really nice job really rolling with that and being prepared to answer questions that you never know what they're going to ask, right?
exactly. Yeah.
Yeah, good. So if you had the chance to have this conversation again or teach this lesson again, Amanda, what do you feel like you might do differently or try to improve upon?
I think maybe having them like parents share with each other to hear
Mm,
each other's thoughts.
hmm
I kind of totally forgot that that was an option to do, but
Yeah.
I think that it would be interesting to see like them kind of
mhm,
teach each other and learn each other's strategies from one another.
Yeah.
So,
I think that's a really great thing to work on next time, right? Of utilizing those, it's because you were doing a really nice job of connecting ideas and asking them to look at Max and Leah's work and really connect it to their own work. But having them pair and share is going to have them also share the ways that they're thinking about solving the problems
right.
and having those conversations.
Yeah. And
Yeah,
sometimes
good.
they kind of can explain it better to each other too
hmm
it, for some things. So
Yeah,
that would definitely help. But
good. Yeah. And then finally, Amanda, what's one thing that you're taking away from this experience that you feel like you can use the next time you face a similar situation in real life?
I think that making sure that you're like learning the strategies that every student is using is something that
hmm
I'll continue to think about and use for teaching as well because it's kind of interesting to see that there are many different ways that you can go about solving problems, especially for
Yeah.
division. And it's nice that, I mean, in today's schooling, there's not just
hmm
one way of solving anymore. So making sure
Absolutely.
that like the students have as many options to problem solve as they can would be
Yeah.
beneficial.
I like that. Yeah, one of the times I noticed when the kids were asking about why start at 50, right? And
Mhm.
you stayed really neutral about that, right? It was like you're allowed to kind of start with whatever number you want to start solving the problems, and then you get to problem solve and figure out what makes the most sense for you.
Right, and I think it was
Yeah.
interesting too that the last kid to share was the one that actually did the same way of problem solving, but used a
Yeah.
bigger number. So it was nice
Mm-hmm.
to
Mm-hmm.
relate back to the first question that was asked. But
Yeah. Good. Well, Amanda, you can stop recording if you'd like. We're gonna